Okay, what we're going to look at here is our USB TTL module. So this is basically a parallel port replacement. So it's 25 way D, your 8 output pins and 8 input pins, and the rest are ground. And that's USB with an activity light and a fault light, basically a standard USB lead on the back. That works on Windows, Macs, Linux systems, basically anything where you can output standard serial at 115 baud. So what we'll do, we'll plug that in and I'll show you that working with our app. I'll show you a diagnostic board plugged into that, and then finally we'll run a little PsychoPy experiment. So I'll just plug the USB lead in there. So it takes a few seconds to power up, so that lets you know that it's powered up. One LED's for in and one's for out, basically, when you TTL event mark. So that might be on an EEG system, an eye tracker, or whatever it is that you need. So what I'm going to do is just plug this homemade diagnostic board in. So basically that's got 8 LEDs that represent the status of the 8 TTL lines for event marking. So if you think about that, that could be into your EEG event marking channel, or your digital in other words. And there's another 25 way pass through which could go in. And these terminals are for building your own cables up and breakouts. So we'll just start our app off, and this just lets you test the outputs, and it also checks to see how fast it's operating on whichever PC, Linux or Mac system that you've got. So basically it's all configured. We've got 8 output lines and 8 input lines, so I'll just go through the output lines. So as you can see, I've turned one virtual LED on there. The red LED on the back has come on to tell you that you've got an output, and you can see that there's a green LED lit there to represent 1. So I'll just go through the lines. So you can see 2, the 3rd line, 4th line. You can see the LEDs light up in turn. So this is what you do from your experiment, from your script. You just output 2 hex bytes. As you can see there, the hex bytes are shown, and that just represents the status of the lines. And then when you want to turn those off, you can basically go through and turn them off. And again, you do that in code. So you've got between 0 and 255 possible states for those 8 lines. So that's an 8-bit port if you think about it. So what I'll do now is I'll just plug one of our diagnostic boards in. So these are quite handy for seeing what comes out in terms of the hex. So in other words, this could be your EEG machine, for example, a digital input. We'll just plug it into the USB for some power. And that tells us at the moment we've got no output pins high, so no output lines for event marking. And you can see the LEDs are all off. So if I go through now, if I do 1, so that's the first line that I've turned on, so that might event mark an image, for example, so the image onset, and we can see that what I've sent from there according to the pins is actually 0, 1, so everything matches. So I can go through and turn the second one on, so that might be another event marker, or it might be when you press the response key, and we can see that the hex to get those 2 LEDs to turn on is 3. And that's what we've sent, and that's what's being received. And if we turn them all on, it should go to FF. Yeah, so you can see we've turned them all on virtually, or in effect from your experimental script. We've got FF on the output there, and all the LEDs on the output board are on. So they'd be the lines that are going into your EEG or whatever digital in you wanted to use. So I'll just turn those all off. So what I'll do now, I'll quit this, I'll unplug the diagnostic board, so I think you get the idea on how that works. And then what I'll do is I'll just run a little PsychoPy study up, and we'll have a look at the LEDs coming on and off. Where are we? There we go. Right, so we'll just run that now in the desktop mode. I'm doing it from the runner, but you could do it from PsychoPy itself. So you can see that as I press the response, the spacebar is event marked. So hopefully that makes sense. You can see that it works from PsychoPy and it's pretty simple to do. So for every event mark, you'd have one line of code that turned a given line or pin on, and then after the event you'd turn it off. So it's quite easy to event mark, and our app's got some timing code in there which will make sure your system can actually event mark on time. We can't account for what experiment generators do. They may or may not event mark on time, even though the hardware is capable of millisecond accuracy, if that makes sense. So whether it can output at the correct time for the correct duration and at the correct point in time is down to the experiment generator and nothing to do with us. To independently check things and to make sure your timing is accurate as well as precise, you should be using a black box V2, V3 or an BBTK, because that's the only way of doing timing that is truly independent of your experiment generator and the PC, Mac or Linux system that you use.